Okay, yeah, thanks for having me. Thanks for being here. So I'm going to talk a little bit today about some of the work that we've been doing on trying to understand how different agents in some sort of multi-actor system, broadly construed, have access to different pieces of information and what impacts that's going to have on the overall outcomes of that system. And so the main question that we're going to be trying to ask and answer today is, what is the role that heterogeneous information play in AI systems? And there's a couple ways we can think about this. I'll talk about one in particular today. One perspective on this sort of information heterogeneity in AI systems comes from human-AI collaboration. And often the goal there is you say, well, my model, my AI system knows something, the people I have know something else, and hopefully they can make better decisions together. And so my goal is to say, can I combine these information sets into some productive way and get something that is better than either in isolation? Okay, that's not what I'm going to talk about today, but we have some interesting work on that if you want to talk to me more about it. A different perspective comes from what happens when I have lots of different AI models acting out in the world somewhere. So I have lots of little robots. They may be going around and doing things. They're producing stuff. They're setting prices. They're making decisions, whatever it might be. And I might think that I'm getting a lot of benefits because I have lots of different robots running around doing things. But it might end up being the case that they all have access to the same underlying set of information. And that's going to correlate their behavior in unpredictable and perhaps problematic ways. And so this is the thing that we're going to be focusing on today. Now, one thing that you might hope for is in this world, maybe it would actually be better if I had a different little model come. Maybe this guy's not very good. Maybe it's not very powerful. But it has access to a sort of a different information set relative to everybody else. Okay? And so in a world where everybody's behaving the same way, it might make sense for me to try to diversify in some way. And so we're going to look at settings where that might be the case and try to think about what is the right way to analyze them. Okay? So I'll talk about a few different papers today, sort of jointly together. This all started with work that we started thinking about in 2021 around what happens when we get monocultures of algorithmic systems, and how should we think about that. Okay, so what is a monoculture? Well, the traditional agricultural notion of monoculture says, if we plant lots of different crops, those are going to be resilient to different things. They're going to fail in different ways. And so hopefully that is going to be a resilient overall system. And I'll contrast that with a monocultural system in which I only plant the same crop over and over again. And the problem with this is, even though this is a pretty hardy plant, it survives with probability 0.9. If there's some virus that's going to come out and target this particular plant, all of my crops are going to die and I'm in trouble. It would have been better if I'd planted a bunch of different things, even if some of them were weak, some of them were going to fail under different conditions, simply because the probability of catastrophic failure is lower, right? They're not all going to fail simultaneously, and that is good for my system, even though any individual plant might actually not be as good as the best plant I could think of. Okay? So this is a common problem that people think about in agriculture. It turns out the analogy actually extends really nicely to computer security. So people think about monocultural issues in computer systems. So if you think we're all running the same operating system, we all have vulnerabilities to the same bugs. And so therefore, if someone designs a virus that targets my Mac, it's going to target all of your Macs, and we're all in trouble. But maybe if some people were using Windows, maybe if some people were using different Linux distributions, whatever it might be, we would have a more resilient overall system. We actually saw a good example of this. This is sort of a tangent, but I had gone to the urgent care because I thought I had broken a bone a few months ago. And so I went in and I got an X-ray taken, and I come out to the doctor and she's like, well, actually, we can't do anything with this X-ray because all of the Windows machines are down. We can't send this to our lab where they would normally analyze it. So, wait a few days and we'll try to look at it and we'll call you if something bad happens. They never called me, so hopefully that means I was fine. But this is a system where you may remember this, this was a few months ago, or maybe, was it a few months ago? Yeah. Everybody's Windows machines crashed, nothing was working, and all of these legacy systems that were built on it were therefore vulnerable. Okay? So that's an example of how we might see monoculture in computer systems. More recently, actually, there's a Gary Gensler, who's a former, I think, Treasury Secretary? SEC, yeah. He had a lot of stuff to say about monoculture in AI systems in finance. So if people are, you have a trading algorithm that's going to make decisions on your behalf based on the information it has available to it. And if everybody is running that same algorithm, if there's some mistake, some weird condition leads to unexpected behavior that could trigger some sort of catastrophic failure throughout the financial system just because there's some sort of weird failure mode that all of these things are simultaneously running into. And these are problems that you don't have with human traders necessarily because, yes, they're going to fail, they're going to make mistakes, but the whole point of the system is that people make different mistakes from each other, right? There's independence across actors, and that actually creates resilience in the system. OK, so how should we think about monoculture when it comes to algorithms and AI, decision-making, prediction, and so on? When is it a bad thing? What sort of risks are we encountering by increasingly adopting AI models? And what are the forces that are going to push back against monoculture in the world that we have today? OK? So I'll take you through a few examples. So one is this initial setting that we started thinking about a few years ago, which is think about a decision-making setting. So we were thinking about it in the context of like resume screening algorithms, sort of these models that are designed to make predictive decisions about people's potential for employment. And firms in this world often face a choice. Sometimes they, in reality, they use a combination of these things. But for simplicity, let's say you face a choice. You could hire a bunch of people to screen resumes, or you could buy some model that somebody sells that screens resumes for you. Okay? And so there's lots of these third parties that now offer machine learned models that say, give me a resume or give me some information about a candidate, and I will predict how good of a candidate they're going to be. Okay, so we could choose to adopt those models instead. Forget about the difference in how fast these things operate or how much they cost or whatever. I'm going to ignore that for now and just think about what is the information they have access to, how much correlation is there going to be in their decisions, and what sorts of risks will that introduce. Okay? And so a caricature of what this might look like is, in a non-algorithmic world, all of my human HR managers have different information sets. They have different biases. They make different mistakes. And so what that means is they're unlikely to fail all at the same time. Right? Another way of saying this is if I go apply to a bunch of jobs and there's a bunch of humans sitting on the other side of that, some of them might like my resume, some of them might not, but at least I'll have opportunity somewhere. Okay? Now, as we start to use more and more algorithms in this space, maybe it's OK if some people are using human screeners and some people are making decisions algorithmically, because I still have some opportunity there. Right? I might find a human who likes my resume, or maybe this particular model likes my resume. But you start to encounter problems when everybody is reliant on the same algorithms. Right? If everybody's just using the same resume screener, then if I get rejected from one job, I'm going to get rejected from all jobs. A different example of this is if my credit score is low, if this bank rejects me for a loan, then every other bank is also going to reject me for a loan. Right? And you could say, well, that's the whole point of a credit score. It's supposed to measure creditworthiness. But obviously, there are idiosyncratic errors that it makes. Right? Some people just have thin credit files. They are truly creditworthy. They have low credit scores. And they're going to be systematically denied opportunity. Okay? Now, so you can see how this might be bad for individuals. The interesting thing that we found when we sort of modeled this out more formally is that this can actually be bad for the decision makers themselves, and yet it is still in their best interest to switch over to using algorithms. Okay? And the intuition I'll give you for this is as follows. For me as an individual, if I'm a firm deciding what to do, it might make me better off individually to start using this algorithm. Right? It is sort of marginally better than the humans that I'm using instead. But when I start using this algorithm, it's actually going to make everybody else a little bit worse off. All the people who are also using the same algorithm as me, I'm going to have an externality on them. So my predictions get better, theirs get slightly worse, right? Because we are converging on this same information set. And so if we all make this same decision, I'm going to get slightly better, everyone else is going to get slightly worse. On average, or across the entire system, everybody still ends up slightly worse off. Okay? And so this is a somewhat counterintuitive result. It's sort of hard to wrap your head around this. But for me, it was a clear indication that there's some value in information diversity, right? That creating these monocultures is actually a negative for society. And it is still a path that we might go down, even if everybody's behaving rationally. And that seemed like a sort of a strange place to be. Okay? So the key observation here is that the negative impacts of monoculture come from these externalities. That when I make a decision, or I choose to adopt some algorithm, it's going to affect everybody else who was also using that same algorithm. It's going to make them slightly worse off because I'm doing the same thing as them. And as long as that is, in many of these cases, that ends up being a bad thing. Okay? So these links between people, or the interactions between people, is really going to dictate what are the bad things that happen when we all start doing the same thing. We all start behaving in the same way. And so there's some key questions that in the next 5 minutes and 29 seconds I'm going to try to explore here. When does us behaving similarly lead to these negative externalities? When is it bad to have similar behaviors as your competitors or your cooperators, whatever it might be? What are the implications for this? And where in which settings should we expect to see more or less monoculture? Okay? So I'll give you two very quick examples that we've been studying throughout this last couple years. One is on algorithmic pricing, so how, when people are using algorithms to set prices, what are the implications there? And the second is on content generation. So when we're using AI to generate some content, again, what are the impacts of monoculture there? Okay, so the example I'll give you to sort of motivate this notion of algorithmic pricing is you're increasingly seeing people try to predict willingness to pay and use that as a factor to set prices. Okay, so for instance, you see this a lot on like travel booking sites, like depending on your location, depending on the device you're using and that kind of thing, they'll show you different prices because they're trying to effectively estimate your willingness to pay and then charge you as much as you're willing to pay. And there's two competing forces here. One is that firms want prices to be high, right? High prices mean more profits. But the second force is firms also want to undercut each other, right? If, you know, Lyft is charging $10 and Uber is charging $9, then I'm going to go to Uber, and that's probably good for them, right? And so the question is, what is the impact of monoculture on these competing forces? So in this example, Lyft gets to decide when they're going to give me a 10% discount. Uber gets to decide who they're going to give a 10% discount to. People are sort of varying degrees of price sensitive, and they're going to make decisions accordingly. And the question I'm going to ask is, as their strategies for offering these discounts become more correlated, what does that do to the market? Is that good for me as a consumer? Is it bad for me? Spoiler, it's going to be bad for me, but for interesting reasons. Okay? And so the punchline is firms may actually prefer to use the same pricing algorithms as each other because that allows them to effectively collude on keeping prices high. Right? If I know that you're not going to undercut me because I know that we're using the same algorithm, we can both raise our prices. Okay? And so this shows that firms in this sort of pricing setting actually have an incentive to correlate their predictions as much as they can, right? Now, this should worry you a little bit. This is a setting where, you know, if they were using different pricing algorithms, I as a consumer could choose my favorite price. I could be sort of shop around and choose the lowest price, and therefore I win as a consumer. And their goal is to say, actually, can they just use the same pricing algorithm? And if so, I don't have any choices anymore, and they can raise the floor on that price. Okay? Now, this is sort of comes from fairly standard economic models. The interesting thing for us here is the legal implications, actually. So I mentioned the word collusion before. You might think of collusion in pricing as sort of vaguely familiar as something that antitrust law is designed to prevent us from doing. Right? Antitrust law says that two firms can't illegally collude to fix prices or to set prices to be high. But it doesn't really appear to apply to this form of algorithmic collusion, right? If firms make rational choices that still, you know, lead me and my competitor to adopting the same algorithm, those might still be individually rational choices. And as a result, antitrust law actually doesn't have a lot of teeth there. But it can still result in these same collusive outcomes that are as if they were able to collude and keep prices high. And so this represents a frontier of antitrust law that the government is actually still grappling with today. And when I say today, I mean like in the last 5 days, the state of New Jersey joined like 10 other states in filing a lawsuit against RealPage, which is a provider of software for rent pricing. Okay, so RealPage goes out to a bunch of apartment complexes and says, we're going to provide you some software. You can use this to price your apartments. And so instead of a world where every apartment is going to be doing their own independent pricing and I as a consumer can come in and say, here's the price that I want for the apartment that I want, you now see everybody sort of hiding behind the same algorithm. Right, and saying we're all going to use the same algorithm to set prices, and as a result, we might be able to use those to illegally or potentially illegally set prices to be above their competitive rate. And so this is what's getting litigated right now between the states and RealPage. Okay, I will very quickly give you the second example of what happens when what should we expect to see when it comes to monoculture in content generation. The stylized fact that I found particularly intriguing recently is you can find a bunch of these studies that effectively find the following. As people start to use generative AI more and more in their processes, you start to see a convergence of the stuff that they produce. Okay? So you see this in creative ideation, in writing, in art production, and so on. The picture version of this is if I ask people to come up with a bunch of creative ideas in a condition without AI, they come up with, let's say, 2 ideas each. If I give them access to AI, maybe they come up with 3 ideas each or more detailed ideas or whatever. And I might look at this and say, great, AI has helped. But then you actually analyze those ideas, and they all kind of turn out to be the same. So even though each individual seems to be producing more, the set of things produced has gotten smaller. Okay, so how should I think about this? There seems to be, at least from my perspective, a force pushing back against this, which is if we're all trying to come up with creative business ideas or whatever, it is not just in my interest to come up with good ideas, it's in my interest to come up with good ideas that nobody else has had, right? I am worse off if we all pick the same ideas or whatever it might be. And so shouldn't that be a force pushing back against it? Shouldn't I be trying to diversify my creativity in some way? Okay, so these are, going back to these externalities that we mentioned, this is a setting where us producing the same thing creates negative externalities for us. It makes me worse off if I do the same thing as you. So how does that propagate back to the way that we're going to use AI? Without going too much into the details, at a very high level, what we find is that more competition incentivizes more diverse production. So the stronger our competition is, the more that my behavior impacts yours and vice versa, the more incentives we have to diversify what we're doing. We also find that the quality of an AI model is therefore multidimensional. Okay? In a world where I'm not competing, maybe one model is particularly good. But in a world where we're competing with each other, I might actually just want to sample from a wide range of good answers. I might not be interested in the one great answer because everybody has that one great answer. And so some models are good at giving you that one great answer. Some of them are better at sort of exploring out into the tail. And it's actually not clear which one, just given a set of models, which one is going to be better. And so what that means is that the market for AI tools is going to incentivize information diversity. In a sense, you get some benefits out of filling a gap left by other tools, right? You see this sometimes where I have a coding question, I go to my favorite model, it gives me the wrong answer. So I'm going to go find a different model and see if that fixes my bug. And if that doesn't work, I'll go on to the next one and see if that works, right? It is helpful for me that those three models are doing different things. If it's the same model over and over again, it's going to get it's not going to be able to fix my bug repeatedly. That's not particularly useful for me as a consumer. And so what I'm hoping is that we end up not with a market that looks like this, where everybody's using the same tool, but actually a market like this, where people just have very different tools that sort of span the spectrum of things that people might want. Okay? And so I'll leave you with this. This is sort of, I didn't get to talk about this for time reasons, but there's sort of two nice ways I like to think about information diversity playing out in AI systems. One is trying to leverage the complementarity between humans and AI, right? So what do humans know? What are AI models good at? How do we put those together? And the second is, how should we think about a diverse ecosystem of tools that have different strengths and weaknesses and allow us to select the thing that works best for us, as opposed to a monoculture where everybody's just using the same product? So if you want to know more about that, there's some QR codes at the top to look at the papers. These are my wonderful collaborators, and thanks so much for your time.
Awesome. Questions for Manish?
So the idea is that the monoculture is just one model. Everybody is sharing that. What if the world we are in is like bi or dual culture? So there are two parts. You're either this way or that way. You hate each other. You don't believe in each other. Then what's going to be happening that way with AI?
Good. OK, so there's maybe one way to sort of interpret what you're saying. So there's some polarization perhaps in the world. Some people believe this, some people believe that. And there's polarized sets of demands of what people want. So I might want a model that aligns with my beliefs. Somebody with different beliefs might want a model that aligns with theirs. I think you're starting to see that a little bit, right? So it's a combination of things. When we build these models, especially the sort of big pre-trained models, they're often pre-trained on whatever data we could find. And as a result, that pre-training process ends up being pretty similar for a lot of these models, right? There's only so much data on the internet. If we all scoop up that same data, we're going to end up with things that look very similar. But on top of that, we have more and more of an ability to steer models in a direction that we want them to go. So if I want this to be very good at coding, I'm going to make it very good at coding. I'll get a bunch of data that sort of makes it good in that direction. If I want it to speak with a particular tone, I'm going to collect data of that form. So that gives a designer actually a lot of degrees of freedom to say, I'm going to specialize the model in this direction, and maybe it's going to get worse at some things, but it's going to get really good at the thing that I want it to do. Now, is it a good thing for society if we start to polarize where people can sort of find the echo chamber model that reflects their own beliefs and reflects that back to them? No, I don't think so. It's not clear to me. And I think this just is a reflection of a lot of the problems that you see with polarized media, sort of broadly speaking, even before AI, right? So you know, polarization was a problem that people started to talk about in social media in like the 2010s, long before we had generative AI. I think some of that is feeding back into these models. Right now, actually, the fact that it is so hard and expensive to train them means that you don't actually see that much sort of split in polarization between them yet. But there's a chance that as they become cheaper to train and people can really self-select the model that agrees with their beliefs the most, you'll actually see more polarization than you do in social media, simply because media has a sort of a networked effect, right? So in order for a social media platform to be useful, there needs to be enough other people using it. Otherwise, it's not a useful media platform. But that's not necessarily true with AI models, right? If I'm just interacting with this model over and over again, I don't need anybody else to share my beliefs. I don't need a platform, a cohesive group of people who all feel the same way. I just need a small number of people who are willing to train the model to behave that way. So I think there's actually a potential for it to get worse than it is on social media, but I don't really have a good prediction as to whether that's going to happen.
Thanks for the interesting talk. I'm wondering more on the content generation sort of side of things. I guess one argument could be that even if you have the same AI being used by everyone is using it differently, right? So as long as you have sufficient variation in the inputs to the AI, even if it's the same AI, the outputs can be still dramatically different.
Yeah.
So given that, how different would this be, say, to like just using a search engine, which would also sort of give similar results to people if you input the same things? But like, where's the key difference here between?
Yeah. This is a great question. So a lot of the variation that you're going to get if people are interacting with different ways are variation in sort of the dimensions in which people know that they want differences. So if I ask a different question from you, we're obviously going to get different answers, and we have to sort of communicate the fact that we want that we are asking different questions in the first place. I'm more sort of interested in the subconscious choices that get made. So one way of viewing what these models are doing is sort of decompression of the inputs, right? I provide some very concise question or something like that, and it blows it up into a very long response. In order to do that, it has to make a bunch of choices on my behalf, right? I didn't specify, what I wanted the variables to be named when I asked it to solve a math problem. And maybe I don't really care that much about that. I didn't specify, the style or the tone that I wanted it to use when it responded to me. It just sort of made a decision on my behalf there, right? And so it's less the higher order bits that I'm worried about, like the actual intent of the query that I'm producing. It's more the lower order bits of the things that get left unsaid, right? The things that I'm not specifying, and it's doing this lossy decompression, it's going to infer a bunch of stuff on my behalf. I think it matters to some extent whether there's heterogeneity there, right? Like I say, make me a clip art that I can use in my my talk here, and it's going to do that in a certain style. It would be nice if different models actually did that in different styles, so there's some more sort of information diversity in the world. That's the kind of sort of diversity that I would see there, and that's even conditioned on us, communicating our intent with the right questions.
Okay, great.
Thank you for this presentation. It was very interesting. I would like to ask one question about an example you made about the rental units. So if there is an AI model which can basically set the price for a unit, how would you get diversification in this area, since most of the owners would just use a model which would maximize their profit? How would you tackle this issue?
Oh, absolutely. I don't think the unit owners or the building owners actually have strong incentives to diversify there. And that's what the law is supposed to do, basically. So the question is antitrust law a sufficient force to push back against that? And I think the current answer is maybe, and it depends on how these cases go, right? So if the courts find that actually all these states suing RealPage have no grounds, and RealPage is just doing something that is sort of economically rational for them and not illegal, then yeah, antitrust law does not have the force required. And at that point, I don't really know what the answer is. I think then you end up with incentives to create a monoculture and no legal recourse for people who think that's sort of bad for consumers.
I'm afraid it's 12:10, so lunchtime. Thank you so much to Manish.